Okay, so here given question number 2, consider a 100 centimeter clear tutorial sheet. Okay.
Yes.
Consider a 100 centimeter square photovoltaic cell with a reverse saturation current equal 10 power minus 12 ampere per centimeter square. Then given two cases, in full sun, okay, in full sun, okay, so in full sun, it produces, that means photovoltaic cell, produce a short circuit current of 40 milliampere per centimeter squared at temperature equal 25 degrees C. Now, this question divided into two parts. Find the open circuit voltage at full sun. Okay, so find the open circuit at full sun and again at 50% of sunlight. So given first at full sun, that means 100% of sunlight, okay, given with area of photovoltaic cell 100 centimeter, given reverse saturation current equal 10 power minus 12, okay, and produce short circuit current equal 40 milliampere per centimeter square, and given temperature. We need to find the open circuit at this case at full scale, or at full sunlight, then again at 50% of sunlight. Then the second part, ask to plot the result. The result which find in part A, now in part B should be plot, sketch the result. So this is part A, find open circuit voltage in two cases at full sun, then at 50%. Then part B, ask to sketch or plot the result. Okay, so for photovoltaic cell, should be given two different current, okay? One of the two current called light generated current of light generated current. This is light generated current, or in ideal case will be I short circuit. Also given other current called reverse saturation current. So in this case, given the two values. So given 100 centimeter, this quantity is from unit, this quantity area. So given area in centimeter square, so area, this is the data, area equal 100 centimeter square. Okay, reverse saturation current, the symbol of this current is I naught. So the reverse saturation current called I naught, given 10 power minus 12. Anyone remember this unit, 10 power minus 12?
Pico.
So pico ampere per centimeter square. So given current with respect to unit area. So current saturation current equal 10 power minus 12 ampere per unit area, centimeter square. Okay, now in full sun, 100% of sunlight, given this BV, okay, produce I short circuit equal 40 milliampere per unit area again. Okay, and temperature in this case at 100% of sunlight equal 25 degrees C. This is the room temperature. Okay, these 2 points at full sun. Okay, now ask to find, find two parts. First part A, find the open circuit in two cases at 100% of sunlight, or called full sun. We will say no problem. Okay, so try to solve this question. I can't written anything. So I'm back now to return the data again. Okay, so given area, given area equal 100 centimeter, given I saturation current equal Vico 10 power minus 12 ampere per centimeter squared, then at full sun, given two values, I short circuit equal 40 milliampere again per unit area. Also given temperature equal 25 degrees C. And asked to find, in first part, find V open circuit at full sunlight, 100% of sunlight, then at 50% of sunlight. Then in part B, also asked to find, to sketch, plot or sketch the result. Okay, clear? The given data. Okay. Okay, clear?
Yes, miss.
Yes.
So we'll start now. We'll solve now. We'll find the starting from open circuit voltage. How to find open circuit voltage? We'll give the equation. This is standard for photovoltaic. So V open circuit, okay, equal to K times T over Q, then ln of I short circuit over I naught, then plus 1. When given ideal case, will be I short circuit, otherwise will be the current given in a question. So we are now using the ideal case because given I short circuit in a question. So I short circuit with respect to saturation current, reverse saturation current. So this is the node, should be given this value in unit of volt. Now we're starting with first case with full sun, okay, 100% of sunlight. Now we have I short circuit, we have also I saturation current. So we need the three other values, K, T, and Q. T, this is temperature. We have temperature, at room temperature 25 degrees C, okay? So we need two values, two extra value, K and Q. These two values are constant. Anyone know this value? We're starting from Q. I think all of you know this value. Q, you see before. Q,
Electrical charge, no?
okay, yes, electric charge equal to, so Q, this is constant, called electric charge. This value equal to 1.6 times 10 power minus 19. Yes. Then K, we need the value of K. K also constant. K is Boltzmann constant.
1.8 something.
Boltzmann's constant, where K equal 1.38. 1.38 times 10 power minus 23 joule per Kelvin. Okay? So if back to our rule now to find the open circuit, when given K times T and K Boltzmann constant given in joule per Kelvin, so should be know the value of temperature should be in which unit? Should be in Kelvin. Kelvin. When substitute K by unit J, joule per Kelvin, so Kelvin will cancel with Kelvin in temperature. So we need now to change temperature to be in Kelvin. Okay? So how to find temperature in Kelvin?
25 plus 2.
273.
So plus 273. Also we need to substitute by I short circuit and I reverse, I not. So given the two values of current with respect to area should be, we know the current will be in ampere, so without unit area. So should be find first the current, the short current, and the reverse current to be in ampere. So we need to, okay, to find all of this value as in a standard unit. So we're starting from I, okay? I naught equal, given equal 10 power minus 12, okay? Ampere per centimeter squared should be given in ampere only. So how to change? I will change first to be clear, over per unit area, centimeter squared. We need in ampere.
Multiply with area.
So multiply by area. So multiply by area equal to, given in this equation, equal to 100 centimeter. We need to change this area, the unit. We need to change to meter squared in this case.
No.
No, because given current, saturation and short current with respect to area in centimeter squared. So we'll use direct. So this value will be times 100 centimeter squared. So centimeter counts. Saturation current equal to, in ampere, ten power minus 12 times 100. 100 means 10 power 2. So equal, level 4.
10 to the power minus 10.
10 power
10
minus 10,
Yes.
yes, ampere. Then also we need to change again the value of I short circuit. I short circuit given equal 40 milliampere per centimeter square. So should be changed milliampere to be ampere. Also cancel the value of area, centimeter square. So this value will be 40, change milli to ampere. Change milli to ampere.
10 to power minus 3.
Minus 3, yes, ampere per centimeter square, then times area, again 100 centimeter square. So again centimeter will be cancelled, then this value will be in ampere. Only 4, because given now in this case 10 power minus 3 and we have 3 zeros and 100 2 zeros and with 40 1 0, so cancel 10 power minus 3 with 10 power 3, so remains only 4 ampere. Okay, clear? We need extra points or extra steps to change any unit? No, only temperature now. Temperature will be in Kelvin. Temperature equal 25 degrees C. So it should be changed to Kelvin. So plus 273. So temperature will be in Kelvin.
to 298.
So 298, yes, Kelvin. Okay. So now can substitute in given rule, okay, by first case when given the 100% of sunlight. So in case 1, part A, okay, first at 100% of sunlight, okay, full sunlight, will be V open circuit equal to K given, T also given, so this is standard at room temperature, over Q. And if given in exam this value at 25 degrees C, this value direct will be 0.0257. Most of time given as a standard at 25 degrees C. If given at 25, so K constant and Q constant, and with respect to this temperature, we'll find this component or this term will be 0.0257. So this is the first time, so we'll substitute. So K equal 1.38 times 10 power minus 23 times temperature, where temperature equal 289 over Q, and the Q equal 1.6 times 10 power minus 19. This value called KT over Q. This value equal 0.0257. Then ln of I short circuit at full sun equal, we find it equal I short 4. So 4 over, then always reverse saturation current, always small
Plus.
current. So 10 power minus 10. Okay, then plus 1. So please find this answer. This value, the first term, equal to 0.0257. Then find ln of 4 times 10 power plus 10, or divide by 10 power minus 10 plus 1. Find V open circuit.
Zero 0.627.
Yes, 0.6274 volt. This is the output voltage, open circuit voltage, okay, at full sunlight. Again, We need to find again this value, but now at 50% of sunlight. What is the difference now between two cases? حد يعطينا note? What is the difference? Given in a question, when given data, given the short circuit current at full sun equal 40 milliampere, we find as a milliampere change with respect to time, with respect to area, we find equal 4 ampere. Now, in next case, when we have now 50%, okay, half of sunlight, 50% of sunlight. So what's the change now?
Will be half
This,
current.
yes, now because of I short circuit is proportional to solar intensity. So at 100% of sunlight was 4 ampere. Now in 50% of sunlight will be half, 50% of value. So 50% of 4 will be 2 ampere. So this depends only on current because saturation current same, should be same. Only change in I short circuit. So for the second part at now 50% of sunlight, okay, because of short circuit current is proportional
أعلق بعده.
نفس المشكلة. I don't know what's the problem here always. Stuck again. So sorry, I will leave and back again. So for a second case, at 50% of sunlight, there is a problem with the network. I can written anything. So please try to find this answer for 50%, okay, I will send to you the solution later, okay? Please return this note. At 50% of sunlight, okay, the I short circuit is proportional to solar intensity. Therefore, I short circuit will be, okay, half of 4 in previous case, so will be 2 ampere. Then we'll substitute in rule. So the first term will be same, 0.025. I'm sorry for this problem. Okay, so at 50% of sunlight, anyone find this answer? Because of a short circuit.
0.6095.
Yes, proportional to solar intensity. Therefore, I short circuit in this case will be 2 ampere. You know from where? because before and 100% of sunlight was 4 ampere, so now will be 50%. Therefore, V open circuit will be same note, same rule, will be K times T over Q. So this answer equal to 0.0257 when substitute in previous step. Then times ln of I short circuit now equal to over saturation 10 power minus 10, then plus 1. So this answer will be 0.6 then?
0957.
Yes, 0.957, so 6 volt, yes. Yes. Now, this is the answer of first part A. We need to answer now the second part. Ask to plot the result. Plot the result which find in part A. We find in part A the relation between, we find the relation between what?
Voltage.
Voltage with respect to current. So we need to sketch now in this case the VI curve with respect to photovoltaic cell. So this is standard for NB junction for solar PV. We need to sketch now the relation between, this is part B, the relation between voltage and current. So this is voltage in x-axis. This is voltage in volt called V open circuit, okay? And current, which current? Which current? Short circuit current should be short circuit because saturation same, not different, okay? So I short circuit, okay, in ampere. Now we have two cases. When given the value, we have value of current short circuit equal 4. That's given for full sunlight. Also given 2 ampere at 50% of sunlight. So we have two cases. So in x-axis, in y-axis, I mean for current, we have two cases. Starting from 0, so we have 2 ampere and we have 4 ampere. 4 ampere for full sunlight and 2 ampere for 50% of sunlight. Also we have the open circuit. We find this value equal 0.6 in two cases, but we have different value. Point in case 1, 0.6, approximately 0.63. Then for second case at 50% will be 0.6, approximately 0.61. So we can take as standard in for this case for x-axis, we can take every 0.1, okay, volt, every 0.1, depends on you, okay, up to you, use any scale. If take as 0.1, because we need 0.6 in two cases, 0.63 and 0.6, okay, 2, so can take 0.2 or 0.1. So if take 0.1, so it will be 0.1, then 0.2, 0.3, 4, then 5, 0.6, 0.7, so we have 2.8, for example, okay? So for the first case, for the full sun, okay, light at 4, so this is the short current, at the open circuit 0.63, approximately 0.63, so before 0.65, so in this point, okay, this point, approximately at 0.63, okay? So how to be the curve of voltage with respect to current or current with respect to voltage for PV cell? This is standard. Should be, okay, steady state for short current till, okay, period depends on the open circuit now will be now dropped like this. This is the standard one, the standard curve. Okay, this is the standard curve for IV curve. This is the curve. So this case for full sunlight. 100% of sunlight. Okay, approximately this value equal V open circuit equal 0.627 volt. Other curve now for next part, when given 50% of sunlight, okay, at 2, also equal 0.6 less than previous one, so will be like this. So this is at 50% of sunlight. Okay, clear? Okay, this is V open circuit now for second case equal 0.6096 volt. Okay, so this is the part B. Okay, clear?
Clear, Miss, clear.
Okay, so this is the first question number 2. This point, okay, before dropping in value, this point for each curve, okay, given in this point, given I maximum with V maximum. So this is V maximum for first curve. So this point will give the power maximum. With respect to I maximum, always I maximum less than short circuit current, less than. So for full sunlight, okay, curve, given I short circuit equal 4. So I maximum will be less than 4, less than 4. Also V maximum will be less than 0.627. So the multiplication between the two values will give the power maximum at this point, okay? This is only a note, we'll see in lecture note for this week, inshallah. Okay, clear? Okay, now we'll go to question number 3, same idea. Okay, with different data only. And the different illumination, the cell of question number 2, which is solving now, delivers 5 ampere into a short circuit. So 5 ampere, this is the I short circuit, okay? The reverse saturation current equal 1 picoampere per meter square. So this is I reverse saturation current given in picoampere per meter square. Now question same. Find V open circuit at temperature equal 300 Kelvin. So now given temperature direct in Kelvin and asked to find V open circuit. We need extra value to find V open circuit. We know V open circuit in general equal KT over Q ln of I short circuit over I saturation plus 1. So from this rule, we need extra information. Should be yes, because given in this question, okay, asked to refer to question number 2. So we need extra information from question number 2. Which information we need it here?
Temperature.
Given temperature equal 300
Area.
Kelvin. We need area. Why we need area? Because given I saturation current with respect to unit area, with respect to meter square. So we need to find it at ampere only. So should be used from previous question, area. So area in question number 2 equal 100
centimeter square.
Yes, given in centimeter square in previous question. So 100 centimeter square. We need to change to meter first because given I saturation now in meter, per meter square. So please change from centimeter to be in meter square. So will be, in the previous question, we didn't need to change to meter square because given current in with respect to centimeter. Now we need to change. Anyone given the value of area in meter squared will be times what? Times 10 power?
10 power 4
minus
because
6.
square.
So 10 power? Change from cent.
Minus 6.
-4.
هذه المصادرة كانها